Okay, so let's start with enzyme. First, you need to know what's the definition of enzyme. Define enzyme. There are 3 points that must be present when you define enzyme. Number 1, enzyme is a biological catalyst.
Yeah, bro.
Enzyme will speed up rate of chemical reaction and it remain unchanged. At the end of the reaction. So these are the 3 points that you need to know. It is basically found in your notes. There is a small blank space there where there are 3 dashes. I want you to fill it up with this. Is that okay? Milton?
Yeah, okay.
Once you're done copying, you let me know. Huh?
Yeah, I'm done.
Okay, so basically when they ask you to define enzyme, you have to include these 3 points. So how are you going to write? Just say enzyme is a biological catalyst which speed up rate of chemical reaction and remain unchanged at the end of the reaction. Very easy. Then let's take a look at the characteristic of enzymes. The characteristic of enzymes include these 3 plus something more. So biological catalyst here, what does biological mean? Biological means something that is, bio here means things that are alive. So biological here means within living range. That means out of certain range of temperature, there is no living things. So in that case, enzymes will not work during that range. Like say, for example, humans live well around the range of 37 or 36.9 degrees Celsius. That is how their body operates. So you can find enzyme within that temperature, but you can't really find a lot of enzymes that works best in maybe 100 degrees Celsius or 1000 degrees Celsius or 2000 degrees Celsius. Why? Because most living things don't live at 1000 degrees Celsius or 2000 degrees Celsius. They don't live there, they will die. So the biological here tells you that it works within a certain range. In this case, what kind of range? Sorry, I just removed a teeth, so my pronunciation is not very good. After I remove my stitches, my pronunciation will be better. So biological here means they works best within a certain pH range and works best within a certain temperature range. Catalyst here means speed up chemical reaction. So it's already mentioned over here. Remain unchanged at the end of the reaction here imply 2 things. If it remain unchanged, then it can be recycled. Right? Because after the reaction, you're going to get back the enzyme. So of course you're going to reuse it, right? You won't go and destroy it, correct? Yes, Milton?
Yes.
Yeah. So you can use it again and again and again and again. if something that can be used again and again, you're going to make it in small amount, not large amount. Okay, so it's normally made
Okay.
in minute amount. Why? Because it can be recycled. So after some time, it is regenerated, then you can have it again. So what's the point of making so much of it? After all, you're going to use it again and again and again. Okay, just like you have a jeans. Your jeans, you can use it again and again and again. So you don't need like 200 jeans for 200 days, right? You can wear the same jeans for maybe a few days, then you wash it, then you use it again. So for the 200 days, you only need like 2 jeans. You understand what I mean?
Yeah.
Okay. So these are all the implications. Plus, of course, there's one more characteristic that is not mentioned in the definition. That is specificity. Specificity. That means enzymes is very specific. In other words, say I have enzyme A. Enzyme A can only digest substance A. It will not be able to digest substance B. You understand what I mean?
Yes.
Okay, I'll give you an example. Say I have starch. Starch is digested by enzymes amylase. Amylase will digest it into maltose. That is the job of amylase. Amylase cannot do other job like breaking down protein into polypeptide. That is the job of maybe trypsin. So in this case, amylase can break down starch. Amylase cannot break down protein. Trypsin can break down protein, but trypsin cannot break down starch. They are very specific. Can? So due to this specificity, scientists come up with a model they call the lock and key model. In this lock and key model, they want the students to understand that enzymes are very specific, just like lock and key. The key to your house, the key to the door of your house can only but unlock. The lock in your house can only be unlocked by the key, the very key that you have. If a burglar tries to break it with his own house key, it's not going to work. You understand what I mean?
Yeah.
So this is a lock and key model. Okay, your lock can only be unlocked by one key, not your neighbors, not your friends, not the burglars. So they come up with this lock and key model. Lock and key model is important. It's always like is heavily tested. So whenever they ask you to explain the action of enzyme with reference lock and key model, you must tell the examiner what is represented by the lock first and what is represented by the key. The lock, which is bigger, is represented by, so you can imagine lah, enzymes is bigger, right? Correct?
Yeah.
Substrate is smaller. Lock is bigger or key is bigger?
Lock.
Lock is bigger. So in that case, lock is the enzyme lah. Key will be the substrate. And then if they ask you to give example, you can like say in this example, the lock will be the amylase. The key will be the starch. Okay, if you provide such points, you can easily get 2 marks. Then you can explain about how the key, the lock and key is very specific to each other. Only the right enzymes can break down that particular substrate. Easy?
Yeah.
Yeah, so basically, these are the characteristics of the enzymes that you need to know. And may I know you're pure or combined?
Pure.
You're pure. Okay, so if you're pure, you need to learn about activation energy. So have you copied this down? Can you copy this down?
Yeah.
Mm.
Copy already.
Copy already, good. So wait, what is activation energy? Activation energy, it is simplified into EA, activation energy. Activation energy refers to the energy needed to start a reaction. Like say, for example, I try to react this marker with this marker. When I combine them, they don't really react, right? Correct? Right?
Yeah.
Because the energy needed for them to react is not enough. But if I were to heat them up, what do you predict? When you heat them up, you're
They'll fuse.
energy for them. So they will
Combine.
they will combine together, they will likely melt, combine, react. Okay? So the act of heating is actually the act of providing activation energy. You understand what I mean?
Can you explain again?
The act of providing heat, because I burn it, when I burn it, I provide it with more energy. So that they have more energy. When they have more energy, they can react. Can? So you can think of it this way. I have a starting material. This starting material has this amount of energy. The product has this amount of energy. This is the starting material. We also call it the reactant. Well, this is the product. In order to start the reaction, there is a certain amount of energy needed. Then only you reach the product. Then only the reaction will occur and product will be formed. Okay, so the activation energy is this. Oops. This is the activation energy, EA. Can?
Okay.
Yeah, so enzymes actually lower the activation energy required for the reaction to occur. In other words, this thingy is too small. Let me draw a bigger one. In other words, if I can draw it again, this is the activation energy. And if I have a reaction where there is enzyme or catalyst, it will be somewhat like this. In other words, the EA is lower.
It's lower.
Yes, the amount of energy needed is lesser. If I can give it a number, say this is 60 and this is maybe 80, this is 100. The original reaction without enzyme needs roughly 40 joule of energy for it to complete. But with enzyme, you need only 20. So we call it lower the activation energy needed. You got what I mean?
Yeah.
So you can imagine it as something like this. In a normal reaction, the reactant are like these two markers. They don't spontaneously react with each other. We do have spontaneous reaction happening on Earth, but I'm not going to name some. It's not in the syllabus for now.
Okay.
You can imagine it as two particles coming together, but they don't react because they don't have enough energy. So they will constantly try and collect energy from the surrounding. They will constantly try to collect. So they will collect, after some time collect more, after some time collect more, after some time collect more, after some time collect more. So this after some time actually needs a lot of time. So say this one, you need like maybe 2 days for it to occur. With enzyme, you only need half the amount. So it's like just 1 day. So of course, if the reaction happens within 1 day as compared to the reaction happens within 2 days, which one is faster? With enzyme or without enzyme?
With enzyme.
Yes, that's why enzymes speed up the chemical reaction. That's why enzyme lower the chemical activation energy. It lower the activation energy to speed up the chemical reaction. You got what I mean?
Yeah.
Yeah. Okay, very good. So this is what you need to know, because they will want to test you on whether which one is the activation energy before the reaction. Sorry, before adding catalyst and after adding catalyst. Can?
Can.
One more thing is sometimes they ask you to describe what actually enzymes do. You can actually tell them that enzymes provide an alternative pathway for the reaction to occur. Can?
Okay, can.
Yeah, so you can try the exercises behind.